1. Today's lesson is 1.5, a problem-solving plan using models. This can be found on page 32 of your textbook. And the first part is translating verbal phrases. And let's take, for example, this first phrase, the sum of 6 and a number. In order to translate this phrase, you're going to look for clues about what kind of operation this is going to be. So when we look through here, the clue for the operation on this one is the sum. And sub means addition. So basically what this is saying is the addition of 6 and a number, which would be this one. Now one thing I want to add about addition, these addition problems, is that the order doesn't matter. In other words, you could have x plus 6 and it would still be the correct answer. Let's translate another one. Here is 8 more than a number. Okay, once again, we're looking for a clue to tell us what operation. And here we're talking about more. 8 more than a number. So once again, this would be an addition. And the answer for this one would be y plus 8 or 8 plus y, because the order does not matter. The next one, a number plus 5. And once again, the key to what operation we're looking at is plus. We know that plus means addition. And so this one would be n plus 5 or 5 plus n. Now let's translate some verbal phrases that use subtraction. And here is an example for us to start with. That's an addition one. I must have skipped one. How about this one? The difference of 5 and a number. So once again, what is the key that points out that this is going to be subtraction? It's this word difference. And this one would be 5 minus y. Now, unlike the addition, order does matter. So if you have y minus 5, that is incorrect. The difference of 5 and a number. Let's look at another one. 4 less than a number. And remember, what gives away the operation is less. And so this would be 4 less than a number would be a number, or n minus 4. How about 7 minus a number? Minus tells us that it is subtraction. And so this one would be 7 minus n. And one more. A number decreased by 9. The key word is decreased, which means subtract. And if we translate it, it would be n minus 9. One very important thing to remember is that with subtraction and division, order does matter. Now let's look at some multiplication examples. Here is the verbal phrase, the product of 9 and the number, and the word that tips off the operation is product. And if we translated this, it would be 9x, or 9 times the number. And order doesn't matter once again, so you could have a number times 9, or x times 9. Here is another verbal phrase, 10 times a number. And what gives away the operation? It's times. And this one would be 10n, or n times 10. The order does not matter. A number multiplied by 3. And this word right here tips us off. And this one is going to be 3y, or y times 3. And the last group that we're going to look at is division or dividing. And here is our first verbal phrase. The quotient of a number and 4. And the operation that's tipped off is division, and it's tipped off by using the word quotient. The quotient of a number and 4, which would mean n, or a number, divided by 4. And this one, 7 divided by a number. The operation is tipped off by divided. And in this example, it is 7 divided by n, or a number. And remember, order matters on subtraction and division. Let's look at this one here. 3 more than the quantity 5 times the number. And you want to ask yourself, 3 more than what? 3 more than what allows you to look at this part right here. So the quantity of 5 times the number. Well, that leads me to believe that we can do 5n for 5 times the number. And then we've got 3 more than this. So it would be 5n plus 3. Let's look at another one. 2 less than the sum of 6 and the number. So we want to ask ourselves, 2 less than something. 2 less than what? And less than what is what we're going to look at here. The sum of 6 and the number. So the sum of 6 and a number is going to be 6 plus 10. And 2 less than this means that it's going to be subtracted from this whole thing. So this is where we're going to make sure that we're going to put in parentheses. And now we can apply the rest of it, which is 2 less than. So we'll do minus 2. Now we're on the bottom of page 33. This is example 2, writing an algebraic model. And we're going to go through the way that I want you to solve these type of story problems. The steps that I want you to take are, first, list the facts. Second, write a verbal model. 3, fill in the information. And 4 is solve. Please make sure you have this in your notes. I'm going to keep it up here so that we can see it while we solve the next problem. So I'm going to read the problem. You and 3 friends are having a dim sum lunch at a Chinese restaurant that charges $2 per plate. You order lots of plates of wontons, egg rolls, and dumplings. The waiter gives you a bill for $25.20, which includes a tax of $1.20. Use mental math to solve the equation for how many plates your group ordered. Let's first X. So here are the facts. $2 per plate, the bill is $25.20, and there's a tax of $1.20, which is included. And so here is the verbal model that we're going to use. Cost times plates is equal to bill minus the tax. And starting on the left, we know that the cost was $2 per plate. So we can write 2p. And $2 per plate is going to be equal to the bill minus the tax. So our bill was $25.20 minus $1.20. So if we look at the right side, $25.20 minus $1.20, that gives us 24. So we have 2p is equal to 24. And to get p by itself, we're going to divide both sides by 2. And that leaves us with p is equal to 12, or that the party ordered 12 plates. And here is your homework, page 35. 14 through 46 even.